So we are given that cosine of 90 minus theta is equal to sine of theta, and the same for all of the other other trigonometric properties. So cotangent of 90 minus theta is equal to tangent of theta, and cosecant of 90 minus theta equals secant of theta. And the same for all the other ones. So sine of 90 minus theta is equal to cosine, and just the other way around. It still works. So using this, we can prove, and the distance formula, we can prove what cosine of a minus b is. So the distance formula between points x1, y1, and point x2, y2. The distance formula says that the distance squared is equal to the change in x squared plus the change in y squared. And so the change in x is x2 minus x1, and the change in y is y2 minus y1. So d squared equals x2 minus x1 squared plus y2 minus y1 squared. Okay, so in order to prove the what cosine of a minus b is, we draw a circle and set the center of the circle as the origin. And now we create two arcs. The first arc goes from the x-axis intersecting the circle to point B, and this is arc B, so arc B. The second arc goes to point A, and so this is arc A. And so the coordinates of point A is our cosine of A, comma sine of A, and the point B is cosine of B, comma sine of B. And so now the arc defined by the subtraction of those two arcs is this arc right here. We're going to call this arc A minus B. So this is arc A minus arc B. Now we need to rotate arc A minus B down to standard position. So if we draw another circle, and then we redraw our axes. So now the arc, this arc, will have been rotated, so this point right here is now right at the intersection of the x-axis and the circle. And so that looks like this is point 1, comma 0. And so now this point, which used to be point A, is now cosine of A minus B, because it's the new location, comma sine of A minus B. And so this arc right here is the same as this arc over there, and this is arc A minus B. So now, this distance right here is d. So now we can plug these 2 points into the distance formula. And what we get is d squared equals cosine of A minus cosine of B squared plus sine A minus sine B squared. So the way we get this is we know that these points, the distance here is also d. And since this is also d, then cosine A minus cosine B plus sine A minus sine B, those are your 2 points. So these are the same. The distances are the same even though it's rotated. When we square this out, we get that d squared equals cosine squared of A minus 2 cosine A cosine B plus cosine squared B. And then that plus sine squared A minus 2 sine A sine B plus sine squared B. Sorry, I couldn't fit that on one line. So now we have cosine squared A plus sine squared A, and so we know that's 1. And we have cosine squared B plus sine squared B, so that's also 1. So we're left with d squared equals 1 minus, what is this? And that cancel. 2 cosine A cosine B minus 2 sine A sine B plus 1. So that's d squared equals 2 minus 2 cos A cos B minus 2 sine A sine B. So now we have to do the same distance formula for the rotated arc. So that's this minus this plus the squared plus this minus this squared. So we get d squared is also equal to cosine A minus B minus 1 squared plus sine A minus B sine of A minus B minus 0 squared. So then we square this out and we get that d squared equals cosine squared A minus B minus 2 cosine A minus B plus 1 plus sine squared A minus B. Again, we get that cosine squared of something plus sine squared of something, so that's equal to 1. So this whole thing is, so this is 1 and this is 1, so that gives you 2. So d squared equals 2 minus 2 cosine of A minus B. So now we have our cosine of A minus B. So in order to get to eliminate the distances, that's not what we really care about. What we care about is what this equals to, so we need to isolate this. We set the two d squareds equal to each other. So I'm going to continue that over here. So we say 2 minus 2 cosine A cosine B minus 2 sine A sine B equals 2 minus 2 cosine of A minus B. So then we eliminate the 2 from both sides. So we can cross this out. And then we divide both sides by -2. So we cross this out as well. So we get that cosine A cosine B minus sine A, actually we cross this -2 out as well, minus sine A sine B equals cosine A minus B. There you have it. We've just proved that cosine A minus B is equal to cosine A cosine B minus sine A sine B.